So example number 74, solve the following logarithmic equation. 2 log x to base 2 plus log x minus 1 to base 2 minus log 5x plus 4 to base 2 is equals to 1. So here we can use the laws of logarithm because we have the base 2, base 2, base 2, meaning this one, we introduce log 2 to base, we introduce log 2 to base 2. A log of a number to the same base is 1, isn't it? So we have log 2 base 2 all through. So the next thing we do is to get rid of these coefficients, isn't it? So this coefficient of 2 becomes the power. So there we have log x squared to base 2. Then it is plus log x minus 1 to base 2. Then it is minus log 5x plus 4 to base 2. To be equals to, this one becomes the power. Log 2 to base 2 is 1, isn't it? So there we get log 2 to base 2 raised to power 1. So we now have the same base all through. Are we together? After that, we make each and every side of the equation to be one term, isn't it? So if we factorize out here, log 2 base 2, addition goes to multiplication, isn't it? Division, subtraction goes to division. Are we together? So here we have x squared and this plus between these two logs, meaning this plus, if you remove the log outside, this plus will turn to multiplication, isn't it? So there we'll have x squared times x minus 1. Then this minus will turn to division, meaning it is divided by 5x plus 4. Are you seeing you factorize the log outside? So the moment you bring back the log inside, when you take a log to base 2 inside, this multiplication will go back to addition and this division will go back to subtraction. Isn't it? Are we together there? Yes. So that one on the other side, we also have log 2 base 2. 2 raised to power 1 is just 2. So you can see, we now have log 2 base 2 as a single term on either side of the equation, isn't it? Yes. When it is a single term on either side of the equation, what do we do? You ignore. So if you ignore the logs on either side of the equation, what do you remain with here? X times x, you get x cubed, isn't it? Then x squared, this is x squared times x, you get x cubed. X squared times 1, you get minus x squared, isn't it? Over 5x plus 4 to be equals to, the other side you remain with the 2. The other side of the equation, you remain with 2. So how do you solve this? You get rid of the denominator, isn't it? So you multiply both sides by 5x plus 4. So 5x plus 4 cancels with 5x plus 4. You remain with x cubed minus x squared is equals to 2 times 5x, then plus 2 times 4. Then you bring everything on one side of the equation, isn't it? Are we together? Yes. So you get x cubed minus x squared, then positive 10 coming this side, positive 8 coming this side is equals to 0. So that cubic equation, you check, is the factor theorem working? If the factor theorem is not working, you go to the numerical method. So can you say, start with 1. 1 is equals to 1, then press in the calculator, answer cube minus answer squared minus 10 answer minus 8 is equals to 0. So if your answer is 1, what do you get? Answer cube minus answer square. When you answer 10 minus 8 negative 18, then you test again. When your answer is 2, then we play it's equals to negative 24, then test maybe negative. When your answer is negative 2, maybe no, negative 2 is equals to negative 2, then we play until you get back there 0. So negative 2 is one of the root, isn't it? And you are very happy. So here, we found the first root here, x is negative 2 giving us 0. Are you seeing that? When you put your answer to be negative 2 according to factor theorem, you are getting x to be negative 2 to be equals to 0, the root, isn't it? So it means when x is negative 2, that is one of the roots. Are we together? When x is negative, it's one of the roots. Do you get any other root? Any other root? Let's continue trying. When x is 3, positive 3, negative 20, 0. Is positive 4 giving us 0? Good. So another root we found when x is equals to 4. Are you seeing in factor theorem we are just testing, isn't it? And we replace the calculator. We've also found that when x is equals to 4, we are getting 0. That's why I'm saying in factor theorem, you just test the numbers 1, 2, 3, 4 is enough. And negative 1, negative 2, negative 3, negative 4. Those are enough because these values are very small, isn't it? Are we clear? You will always find some root which is an integer in the problem you are given, isn't it? Then now what is our solution? Because the solution was involving logarithms, the negative solution is undefined. Are you seeing that? So we end up with x is equals to 4 using factor theorem. You just test. You just test where there is x, you test. When x is 1, do you get 0? When x is 2, do you get 0? When x is 3, do you get 0? When x is 4, do you get 0? So the one which gives you the 0 is the root. That is the factor theorem, isn't it? Are we together? Are we together? Very good.